Hello students, we'll continue with the same numerical. Till XC we have calculated 21.22 ohms. This is the capacitive reactance. So substitute in this one, that is R3 I have taken. This is third branch. So third branch resistance 15 ohm minus J. XC is 21.22. Okay, this is Z3 third branch impedance. So therefore total impedance is ZP, which is nothing but 1 divided by ZP is equal to 1 by Z1 plus 1 by Z2 plus 1 by Z3. So 1 by Z1 is 1 by 10 plus 1 by Z2 is, in bracket you take 20 plus J 31.4 plus 1 divided by, you have to take it as 15 minus 21.22 J. Okay, both are same, means you can write J first or last. Okay, now this one we need to solve. So to solve this one, I'm going to use this calci. So just observe only once, I'm going to show you. Right, we have already discussed about this mistake. Make sure that your calci in complex form, that is, okay, initially it will be like this. What you have to do is enter mode and then choose 2, that is complex form. Okay, to do this one, 1 divided by R, means 1 divided by 20, 1 by 10 plus 1 by Z2, 1 by Z3. What you can do is make in bracket, that is 1 divided by Z1, that is 1 by 10 plus second one. Be careful, second one and the third factors are of complex forms. Okay, if you have a higher version of this calci is well and good, you can make use of it. If who have this kind of, then you can just follow it. So 1 divided by, make sure it should be with the bracket. Okay, so Z1 is how much? 20 plus J 31.4. As I told you, J we not have in a calci, I we have, but okay, we are not going to take I in a book. Okay, in a calci we will be taking I, but in a book we are going to write it as J. I told you why we are not going to take, because electrical engineers, we are going to refer I as the current, not a complex number. Okay, J we are, instead of that we are going to take it as a J. Okay, so 1 divided by, what is this? 20 plus 31.4 J. 20 plus 31.4 I. Okay, it is 20 plus 31.I. So close this bracket, and this is for denominator and this is for numerator. Next, plus 1 divided by, start with the bracket, that is 15 minus 21.22 I. Okay, close this twice. Right, take it, this you have got as a 1 divided by ZP, that is 1 divided by ZP is equal to, okay, that is equal to 0.1366. So it has denominator, means imaginary part also. So to get that, we have to enter shift and equal. So you will get plus 8.767. You want ZP, so take its inverse, means 1 divided by that. That can be done 1 divided by answer. Right, 1 divided by answer, you will get 7.288, okay, minus 0.467 I. Okay, so this one, this is called as a rectangular form. Right, as we have discussed in the class, this is a rectangular form. We get in the form of polar, that you have to do it as a at an angle B form. So what to do for that? Enter shift. Okay, here just observe plus mark, it is arrow mark R at an angle theta. So this form we require, so enter it, then you enter this one. So you will get 7.303 at an angle. Again you want a polar form, so shift equal, so it should be minus 3.6. So 7.303 at an angle minus 3.67 ohms. Okay, this is your total impedance. So first task we have completed, right? That is 7.303 at an angle minus 3.67. Okay. Next thing is we need to calculate what is the current, total current. As I told you, so these three are in parallel, so voltage remains the same. Voltage across this branch is also 230 volt. Voltage across this branch is also 230 volt, and voltage across this branch is also 230 volt. Let's take how to calculate this I1, I2, I3. What is I1? I1 is current flowing through the first branch, is nothing but voltage across that branch V divided by impedance of that branch. So voltage across that branch is 230 volt. Okay, you can take at an angle 0. When they have not mentioned 230 in the complex form, you can take it as 230 at an angle 0. Okay, this divided by Z1 is how much? Of this first branch, Z1 is how much? 10 ohm. Okay, it is 10. So you can do it. So in the RLC, you will get it as 23 amperes. Similarly, I2 will be equal to voltage across this divided by impedance of that branch, which is 230 volt, 230 at an angle 0 divided by Z2 is how much? Z2 is 20 plus J31.4. We can write it as in bracket 20 plus J31.4. So we can do this one. As I told you, again this one I'll show you. It should be again in a complex form. This has to be taken. So in bracket, okay, numerator should be 230 at an angle. It is shift. Here you have, okay, this button. Enter at an angle 0 divided by again take a bracket because this is completely complex forms. Okay, then you enter 20 plus J31.4. So 20 plus 31.4, J we not have, so we have I, right? So close this, enter. You get in the form of rectangular, that is 3.319. Okay, shift equal, we get minus 5.21. Okay, this we require in the form of polar. This is a rectangular form. We require in a polar form. So what we have to do is shift and then this plus mark. You will get it is 6.17. Again, to get a complex form, shift equal at an angle minus 57.5. Make sure this is your I2. It is amperes. Okay. Similarly, I3. Similarly, we can calculate I3. I3 is equal to V divided by Z3. That is equal to 230 volt, 230 at an angle 0 volts divided by Z3 is 15 minus 21.22 J. Okay, once you calculate it, and you will get 8.85 at an angle 54.74 amperes. Okay, just remember this, observe this one and this one. This is the current flowing through I2 and this is the current flowing through I3. Just see what is the circuit. It is R, L and R, C. Okay, right? See, this is a pure pure resistance, so it is a pure current. Right, means current has been there, is there. Meaning of this one is 23 at an angle 0 we can write. Okay, so voltage is what? V equal to 230 at an angle 0 volts. So current what we have got 23 at an angle 0 amperes. Meaning of this is angle is 0, 0. So in resistance, that also we can analyze. Voltage and current both will be in the same phase. Angle will be 0. Right? What is this I2? I2 is the current flowing through second branch, which consists of R and L. In RL series circuit, current lags voltage by some angle phi. Okay, this one also you can analyze here. Alright, so similarly, this one is a last branch. Current flowing through third branch is I3, which you have calculated, observe its angle. Current angle is a positive, current angle is a negative here. Okay, this is a positive, right? Meaning of this one is current flowing through this in this circuit is leads voltage angle by 54.74. You can analyze this. If not, don't bother much. Okay, so this is how we need to analyze it, right? Anyhow, we are going to deal with the further few more numericals on this, so you can easily understand it. Okay, so next thing is we'll calculate total current. See, total current is I. So at this point, as we have discussed, so at this point apply KCL, that is apply KCL at point P. Okay, apply KCL. KCL says that current entering to the node or junction will be equal to current leaving. So I is the current entering, so which is equal to this I1, I2, I3 are the currents leaving. So it is I1 plus I2 plus I3. Therefore, you know I1, I2, I3 means you have calculated. So calculate total current, that is I is equal to 23 amperes plus I2 is this one, so 6.17 at an angle minus 57.55 amperes, you take in bracket, plus this I3, it is 8.85 at an angle plus 54.74. Okay, total current is equal to 31.48 at an angle 3.68. Okay, now this is the total current. So second task also completed. Now we'll do third one, which is equal to cos phi. Cos phi is what? Cos of an angle of voltage minus angle of current. Okay, so what is the angle of voltage here? So we know that we can write what is the V? V is 230 at an angle 0. And what about the current of the circuit? We have calculated, it is 31.48 at an angle 3.68. Okay, this is the magnitude and this is the angle. Magnitude and angle. Take cos of angle of voltage is how much? 0, minus angle of current is how much? 3.68. Therefore, cos of minus 3.68 value is nothing but your cos phi. That comes 0.9979. Okay, this is your cos phi, power factor. Okay, now we have calculated third task also. Fourth one is a power consumed by the circuit. See, you know they have given voltage, you have calculated I and you have calculated cos phi also. Therefore, P is equal to VI cos phi. Okay, so therefore P is equal to, substitute all the values as I told you, you're supposed to take its magnitude. V magnitude is 230. As I said, this is magnitude and this is the angle. 230 into current magnitude is 31.48 into cos phi is 0.9979. So total P is equal to 7225.2 watts. Okay, I hope you understood this numerical in a single problem. I have covered everything. Just go through it and ditto you copy in the assignment also. So if any queries, let me know. Okay, thank you so much.